Hello friends, welcome to this online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Vadekar from Department of Electronics and Telecommunication from Matoshi College of Engineering and Research Center, Nasik. Guys, today we are going to discuss the one of the last noisy channel protocol, that is selective repeat ARQ. So let's start with our today's lecture. So before starting our today's lecture, let's have a quick revision. If you remember, in last lecture, we have discussed about go back and ARQ protocol, in which we have seen the different scenarios. What would happen when the frames are lost? What would happen when the acknowledgements are lost? And we also came to know that by using this go back and ARQ protocol, we have improved the efficiency. Whereas in stop and wait ARQ, we were waiting, sending one frame and then we are waiting for the acknowledgement. But in go back and ARQ, we are sending multiple frames and then we are going to wait for the acknowledgement. Today, we are going to discuss a selective repeat ARQ and why we are calling it selective repeat. And last, we are going to discuss about piggybacking. So let's start with our today's lecture. So students, in go back and ARQ, it is very simplified process at the receiver side. The receiver, it is going to keep track of only one variable because the size of that window, receiver window, is only one, and no need to buffer out of order frames. So they are simply discarded. But however, this go back and ARQ protocol, it is very inefficient when the channel is very noisy. Because in a noisy link, a frame has a higher probability of damage, which means that resending of multiple frames, because we have seen in go back and ARQ how the multiple frames are being resent. So the resending, it is uses the bandwidth and it is going to slow down the transmission. So for noisy link, there is another mechanism that doesn't resend n frames or all previous multiple frames. When just one frame is damaged. So only guys, the damaged frame, it is being sent. So that's why this mechanism, guys, it is called as what? Selective repeat ARQ. The frame which is damaged or corrupted or lost, only that frame is need to be sent. So that's why for a noisy link, selective repeat ARQ, it is more efficient. But the processing at the receiver is very, very complex. So let's start with our selective repeat ARQ. Now you can see on the figure on the screen that this is the window which is shown by this gray area, gray region. So first I want to talk about the size of the window. The size of the window, guys, it must be equal to 2 raised to n bracket m minus 1, or it must be 2 raised to m upon 2. So this is should be the window size of selective repeat. So from this figure, could you tell what should be the value of m over here by looking at this window size? So you can see it 0 to 7. It means what? 2 raised to M minus 1 is equal to what? 8. 0 to 7 it is there, right? So M definitely it should be what? 4 minus 1, because M equal to 4, and we have seen M minus 1, that is 2 raised to 3. And as we know, 2 raised to 3 is equal to what? 8. So that's why the window size it is 0 to 7. Now, the left side of this window, it is going to tell you, it is going to indicate that the frames already acknowledged, so you can purge those frames. The right side of this window, it is going to tell you these are the frames that can't be sent until or unless the window it slides over them. And this is the window having again three variables. SF, it is going to tell you the first frame of this window. SN, it is going to tell you the next frame that need to send. And S size, it is a variable which is going to tell you the size of the window. So over here, the size of the window, it is 8. So the frames which is shown in this orange color, it means the frames are sent but not acknowledged. And these are the frames that can be sent. So hope so you understood about this send window. Now talking about this receiver window, as you can see it, the size of the receiver window, it is same as the size of the send window. So over here, two variables are there, Rn. It is going to tell you the next frame that is to be expected. R size, it means the size of the receiver window. This is the left side of the receiver window, that is tell the frames that are received and acknowledged. The right side of this window, it is tell you the frames that can't be received. And this is the window which is going to tell you that frames that can be received and stored for later delivery. The color boxes which is shown in this color, orange color, it is going to tell you these frames are already being received, and which is in this white color, that is 3, 5, 6, 8 and 10, they now need to be received. So this is about a receive window. Now my question is, why window size should be equal to 2 raised to m minus 1, or we can say it must be 2 raised to m upon 2. Why? This is the question. So now I am trying to give the answer to this question. So let's analyze this equation, this question. So first of all, guys, we are going to take the window size greater than 2 raised to m minus 1. So over here, we are going to choose m equal to 2 over here for this example. So as you know, 2 raised to m minus 1, it means what? 2 minus 1, that should be equal to what? 2. So over here we have taken the window size greater than 2. So over here the window size is 3 as shown in this figure. Now you can see the timer, it is being started over there, frame 0 it has been sent. The size of the send window and the size of the receive window it is same, that is 3. So now SF equal to 0 and Rn equal to 0, and earlier Sn equal to 0, that's why frame 0 it has been sent. So as soon as the receiver it is going to receive this frame 0, then this window, receive window, it is going to shift by one slot. So Rn over here is equal to 1 because receiver received this frame 0. But unfortunately, guys, this acknowledgement which is sent by the receiver, it is lost. But since the timer, it doesn't expire, so as the event is already being triggered, now Sn equal to 1, it means the frame 1 it has been sent. So now, since frame 1 it is being received, now the window, receiver window, it is shift by one slot. So Rn get equal to 2. But at the same time, the second acknowledgement sent by the receiver, again it is being lost. But since the timer, it doesn't time out, so frame 2 it is being sent as frame Sn equal to 2. So frame 2 it has been sent. So as frame 2 it has been sent, now receiver it is going to shift by one slot. So as you know, it is sequence number, it is a modulo 2 raised to m. So it means 0, 1, 2, 3. The sequence again it is going to repeat 0, 1, 2, 3. So now as this timer it get expires, then receiver, then the sender, it comes to know that I have sent 3 frames but I didn't receive any acknowledgement. It means something it is wrong. So again frame 0 of this old cycle, it is being resent. But what receiver it is being thinking, Rn in this window, Rn over here it can accept the frame 0 because it is under this receive window. But receiver over it is thinking it is a frame 0 of the next cycle. But unfortunately, it means error being introduced, but it is not detected by the receiver. So this frame 0 it is accepted as a frame 0 of the next cycle, but unfortunately it is the duplicate frame because frame 0 is already there. So that's why the reason why the window size should not be equal, must not be equal to, or must not be greater than 2 raised to m minus 1. So in order to overcome this disadvantage, now we are going to see this example by keeping the window size equal to 2 raised to m minus 1, that is 2. So m over here equal to what? 2. So size of the window it is 2. So you can observe it, the timer starts, frame 0 it has been sent, Rn is 0. So as soon as frame 0 it is being received, now this receive window it is going to shift by one slot and it is going to send the acknowledgement that I received frame 0 and send frame 1, but unfortunately this frame get acknowledgement get lost. But as the event already being triggered and the timeout period it doesn't happen, it sends frame 1. So Rn is equal to 1. So it is going to accept this frame and it is going to shift your receiver window. But as soon as this timer expire, then sender it thinks I sent 2 frames but I didn't receive any acknowledgement. So sender it is going to resend this frame 0. But as you can see it over here, the receiver window, it is expecting frame number 2 and 3. So it already knows that I already have a frame 0. So this is the duplicate frame. So it is correctly discard this duplicate frame. And then it is going to send the acknowledgement that I want frame 2. So if this acknowledgement reach over here, then sender comes to know that my frames are being received by the receiver, that I need to send the next frame, that is frame number 2. So in this way, selective repeat ARQ, it is correctly discard the duplicate frame if the window size is equal to 2 raised to m minus 1, or we can say 2 raised to m upon 2. So these are the two comparative windows that we have studied, size of the window, that it must be equal to 2 raised to m minus 1, whereas it must not be greater than this. So as I already told, in selective repeat ARQ, the size of the sender and receiver window, it must be 1/2 of 2 raised to m. Now, One example we are going to take it, which is going to show how selective repeat behaves, similar to the example that we have seen in the previous lecture. But one main difference is the number of timers, guys. It means here each frame sent or resent, it needs a different timer. So we need to number the timer as like 0, 1, 2, and 3. And the timer for frame 0, it starts at the first request but stops when the acknowledgement for this frame arrives. So you can see this. You can see the size of the window over here. It is 4. So frame 0, it has been sent. So as receiver, it was expecting Rn equal to 0. And as soon as it received frame 0, the receive window shift or slide by one slot and it sends ASCII 1. So as soon as acknowledgement 1, it has been received by this sender, then timer it gets stops over here and the send window it is slides by one slot because ACK 1 it has been received acknowledgement 1, which tells that I got frame 0, now I am expecting frame 1. Now guys, the timer for frame 1, it starts at the second request. We have seen about frame 0 and restarts when a NAC, that is a negative acknowledgement, arrives. And finally, it stops when the last acknowledgement arrives. Also, the other two timers, it start when the corresponding frames are sent and stop at the last arrival event. So you can see it over here. So for frame 1, see this timer 1 it has been sent. Earlier timer 0 it has been there. Because for each frame we need a different timer. So frame 1 it has been sent. Unfortunately, this frame is lost. As soon as this event is already being triggered and timer it is not expired, then the sender it is going to send the frame 2. So receiver Rn equal to 1. But over here in selective repeat ARQ, receiver window it can accept this frame 2. Why is it so? Because frame 2 it is present in the window of this receiver, although Rn equal to 1. So it accepts this frame 2, but it sends NAC 1, that is a negative acknowledgement 1, which indicates that I didn't receive frame 1. After that, again frame 3 it has been sent. Again the receiver it is going to keep the copy of this frame because it is present under this window. But as soon as this negative acknowledgement 1 it is received by this sender, it comes to know that frame 1 it is a damage or it is corrupted or it is being lost. So the timer it stops over here and it going to restart. See the restart, the timer it restarts over here and the sender it is going to send the frame 1 again. And then as soon as receiver it is going to receive this frame 1, then this receiver window it is going to shift slide by 3 slots because it received these 3 frames and it is going to send the ACK4. Over here ACK4 it is a cumulative acknowledgement which tells I received frame 1, frame 2 and frame 3. Now I am expecting frame number 4. And you can observe this on the screen that for each frame there is a different timer. Frame 2, timer number 2, frame 3, timer number 3 it is there. Right? So what you can conclude, or what are the the points that we have concluded from this example? So now you can see it. At the receiver side, we need to distinguish between the acceptance of a frame and its delivery to the network layer. Because at the second arrival, guys, frame 2 arrive and it is stored and marked, but it can't be delivered because frame 1 is missing. I mean to say, although it is going to receive the frame 2, but it is not delivering the frame 2 to its network layer because it wants all the frames in sequential manner, in properly uh, ordered, although it is going to store in its buffer. So that's why the frame 3 arrives and it is again marked and stored, but still none of the frames can be delivered to its network layer. And only at the last arrival, when a final copy of this frame 1 it arrives, then frames 1, 2, 3 can be delivered to the network layer. And there are two conditions for the delivery of the frames to this network layer. First, it is a set of consecutive frames must have arrived. So this is the first condition. And secondly, the set starts from the beginning of the window. So please observe this figure, what I have told, that receiver, it is going to receive these frames 2 and 3, but until or unless it didn't receive this frame 1, it can't deliver frame 2 and 3 to its network layer because it wants in sequential manner. Now, the last topic of today's lecture, it is a piggybacking. Now, what is piggybacking, guys? So basically, it is a method to combine a data frame with an acknowledgement. For example, now you can see the station A and station B both have a data to send. Earlier, what we have seen the example, it is of unidirectional for the data. But nowadays, guys, it may happen that both the stations, sender and receiver, we are not talking about sender and receiver, we are talking about the stations. Stations A, it has a data to send as well as it needs to receive. Similarly, B also has a data to send and needs to receive from station A. So instead of sending the data and acknowledgement frames separately, station A, it is going to send a data frame that includes acknowledgement also. See, frame 0 and acknowledgement 0. Similarly, B, it has a data frame 0 to send to A and it is going to send ACK 1. It means what? That it tells A, station A, that I received your frame 0, now I am expecting frame 1. So sender, it is going to send the frame 1 and station A, it is going to send ACK 1 to B, which tells B that I received frame 0. Now station A, it wants frame 1. So station B, now it sends frame 1 and ACK 0. So guys, piggybacking, it can save the bandwidth because the overhead from a data frame and acknowledgement frame, it can be combined into just one frame. So students, today we have seen selective repeat ARQ. Why we are calling it selective repeat ARQ? Because it is going to save the bandwidth and it is not going to slow down the transmission, because instead of only one damaged frame, it is going to send that particular selected frame instead of sending the multiple frames. Then we have seen the scenario, what would happen when the frames are lost, when the acknowledgements are lost, and why this window size, it must be equal to 2 raised to m by 2. And after that, we have seen about piggybacking, that in order to combine the data and the acknowledgement in just one frame, in order to save this bandwidth, Here it is a assignment. You have to solve this assignment and submit it to my email address. And in next module, guys, we are going to start with the new topic, that is error detection and correction. So it's all about today's lecture. Thank you very much.